Hello everyone. In today's continuous lecture of overcurrent protection, we will study a very small topic, that is time graded and current graded system. But this is very important topic regarding the overcurrent relays. So first we need to know what is the overcurrent protection scheme for basically feeders, ringman systems or parallel feeders, where we can use the concept of time grading and current grading. So basically, if I'm talking about overcurrent protection scheme, these schemes are basically widely used for the protection of distribution lines. Distribution lines, that is radial feeders, may be sectionalized and two or more overcurrent relays may be used. One relay used for the protection of each section of the feeder, and if any fault occurs beyond the any point, the circuit breakers at substation will be or should be tripped. So the selection protection principle affects the operating speed of this protection scheme, which has a significant impact on the harm caused by short circuits. Basically, the faster the protection operates, the smaller the resulting hazards, damage, and the thermal stress will be. Further, the duration of the voltage dip caused by the short circuit fault will be shorter the faster the protection operates. So basically, overcurrent relay, we know that the overcurrent relay basically play dual roles. Dual roles, that means both primary and backup protection. For example, if it is used in a radial distribution system, there may be more feeders downstream. So good and reliable selectivity of the protection is essential in order to limit the supply interruption to the smallest area possible and to give a clear indication of the faulted part of the network. This makes it possible to direct the corrective action to the faulty part of the network and the supply to be restored as rapidly as possible. So basically, we need to make more attention for the operating speed of the protection scheme, which can affected by a proper selection of the applied protection principle. So the selective short circuit protection can be achieved in different ways or depending on different system conditions. That is, the following schemes may be the time graded system, the current graded system, and third one is combination of time and current grading, and time and current graded protection, time and direction graded protection. But here I will only discuss time graded system and current graded system in detail. So now we move to time graded protection. Basically, if I am talking about the time graded system, so this scheme is basically definite time overcurrent relay are used for this type of protection scheme. When a definite time relay operates for a fault current, it starts a timing unit which trips the circuit breaker after a preset time, which is independent of the fault current. The operating time of the relay is adjusted in increasing order from the far end of the feeder. If I am talking very straightforward way, then we will say that the obtaining selection protection is to use time grading. The principle is to grade the operating times of the relay in such a way that the relay closest to the fault spot operates first. Time graded protection is implemented using overcurrent relays with either definite time characteristics or inverse time characteristics. Moreover, if I am going to deeply, the operating time of definite time relay does not depend on the magnitude of the fault current, while the operating time of inverse time relay is shorter the higher the fault current magnitudes. That means we already learned the inverse time relay and definite time relay in previous lecture of overcurrent protection scheme, where we already aware that the definite time relay does not depend on magnitude of the fault current. At the same time, the inverse time relays are basically shorter the higher the fault current magnitudes. The time graded protection is basically best suited for the radial protection scheme or for the protection of radial distribution systems. Here we will see that basically this is the feeder time of protection diagram that represent here. Here we will see that The difference in the time setting of two adjacent relays is usually kept at zero point 0.5 second. This is 1.5 second, this is 1 second. That means there will be difference of 0.5 second. The difference is to cover the operating time of the circuit breakers and errors in the relay and current transformer. With fast circuit breakers and modern accurate relays, it may be possible to reduce this time further to either 0.4 second or 0.3 second. We will reduce this time by using the modern actuating relays. Now, if I am talking about when a fault occurs beyond C, that means at this direction, all relays come into action as the fault current flows through all of them. All of them. The least time setting is for the relay placed at C. This is 0.5 seconds. This is the least time setting. So it operates after 0.5 second and the fault is cleared. Now the relay is at A, this point. Now the relay is at A and B are reset. That means these two relays are this time in reset condition. If the relay or circuit breaker at C fails to operate the fault, then the fault remains uncleared, and in this situation after 1 second the relay at B will operate and the circuit breaker at B will trip. Now if this circuit breaker of point B is failed to operate after 1.5 second, then the circuit breaker at point A is operate and then clear the faulty sections and circuit breaker will be tripped. If I am talking about some drawbacks or some limitations of this scheme, so unfortunately I will say that the faults near the power source, the operating time is more. If a fault occurs near the power source, it involves a large current and hence it should be cleared quickly. This is the basic limitations or drawback of this time graded scheme. But in another side, this scheme takes the longest time in clearing the heaviest fault, which is undesirable because the heaviest fault is the most destructive for our equipments which is used in power system or distribution system. So after these drawbacks, this scheme is basically suited for a system where the impedance, that means distance between substations, is low because the drawbacks is that the fault near the power system source, its operating time is more. So if we can use this scheme, if we want to use this scheme, then we can use very suitability for a system where the impedance or distance between substations is quite low. It means that the fault current is practically the same if a fault occurs on any section of the feeder. This is true for a system in which the source impedance is more than the impedance of the protected section. So I am saying that one important point is that we will use time graded system, but this time graded system is some drawbacks regarding their selection of time because the clearing of heaviest fault in this scheme is very longest time take. So and we can't afford this type of longest time requirement for clearing the heaviest fault. So this is the major drawback for this type of graded scheme for the power system or distribution line system. So we will now move to the current graded system. Now we look at what is the difference in these two systems and what is basically current graded system. So if I am talking about current graded system, so an alternative to time graded or in addition to time graded, current grading protection can be applied when the impedance between two substations is sufficient. It is basically based on the fact that the short circuit current along the length of a protected circuit decreases with the increase in distance between the supply end and the fault point or faulty section. We also say that term. And if the relays are set to operate or initiate operations at a higher current, the supply end, then the drawback of long time delays occurring in graded time lag system can be partially overcome, and this is basically known as current grading. The current grading system basically use the high speed, high set relays, which is IDMT relay we will use for the current graded system. In current graded scheme, we can also say that the relays are set to pick up at progressively higher values of current towards the source. That's why in this type of scheme we will use very high speed instantaneous overcurrent relays. The operating time is kept the same for all the relays used to protect different section of the feeder. The current setting for a relay corresponds to the fault current level for the feeder section to be protected. Here we will see in this figure a simple current graded protection scheme which is applied to a radial feeder, which is shown in a diagram. Here it consists of basically high set overcurrent relay at point A, B and point C, with settings such that relay at A would operate for faults between A and B, the relay at B for faults between B and C, and at the same time the relay at C for the faults beyond the point C. This is the orientation for the circuit breaker or relays which is used in A, B and C. So in practice, the protection schemes poses some difficulties which are mentioned here, and the difficulties is that basically the relay at A is not able to differentiate between faults very close to B. That means this relay which is placed at point A have not the ability to differentiate between faults very close to B. That means this very close at fault B is either operated by the section of B and C protection zone relays which is installed at B. If a fault in the section BC is very close to the station B, the relay at A understand that is in section B. That means if fault is occurs after section B, just after the section B, which is come in the section for BC. So for this ideally for this condition, the relay which is installed in B will be operated, but the relay will not differentiate, or either the relay will understand that the fault at this point will occur in section of AB. So the relay at A understand that is in section AB. This happens due to the fact that there is very little difference in fault currents if a fault occurs at the end of the section AB or in the beginning of the section BC. Second difficulty is that the magnitude of the fault current cannot be accurately determined as all the circuit parameters may not be known. During a fault, that is the third difficulty which is come in current grading system, is that during a fault there is a transient condition and the performance of the relay is not accurate. Due to some transient condition occurs in our system, and during this transient condition the performance of the relay is not properly accurate. So to obtain proper discrimination, relays are set to protect only a part of the feeder, usually about 80%. That means if we are talking about the relay A which is used for the protection of the protective section of AB, 100% AB. So if we want to proper discrimination by the relay which is used in point A, and we need to set this relay to operate only for the 80% of this section. So when we will use this relay for the 80% of this section, that means now this relay will discriminate the fault when the fault occurs at just point B, either just after the BC or after just previous the BC. At this condition, this relay will discriminate the fault is either in AB side or either in BC side. But since this scheme cannot protect the entire feeder, this is the feedback, this is the drawback. That means if we will set 80%, the another drawback is that. So another drawback is the scheme cannot protect the entire feeder, which is 100%, which means this relay which is used in A is not protect the 100% protective zone of AB. It only protect the 80% of AB. So it may be used in conjunction with ID-empty relays. The performance of instantaneous relays is affected by the DC component of transients. So this is basically the drawback of current graded scheme. The current graded scheme is used where the impedance between substations is sufficient to create a margin of difference in fault current. For such a system, the source impedance is smaller compared to the impedance, that is Z1 or Z2. We have assumed any one value, and thus precisely the advantage of this system as compared to the time graded system is that the operating time is less near the power source. And we earlier said that or seen that the drawback of the time graded scheme is that the near the power source fault the operating time is more, but in current graded system the fault in power graded system then the operating time is less. This is the difference in between time graded and current graded system. So in a time graded system we understand the fact that when the fault occurs at point C, then all three relays will be operated. First, if till 0.5 second the relay will not operate, then the after 0.5 second the relay point B is operated for same fault which is occurs at beyond the terminal C. When relay which is at point B is not operated, then after 1.5 seconds the relay installed at point A will operate and trip the circuit breaker at A. This is basically time graded. We will provide the relay with proper time grading, that is difference of 0.5 second. We also used 0.5 second or 0.3 second, which is possibly used by the modern actuated relays. And current grading, that means we will here grading the current, that means we will provide the zone. This zone will be, that means here we will use the 12.5 ampere, 10 ampere and 5 ampere. That means when current the current flow greater than the 5 ampere, the relay will operate, which is used in C. When the current is greater than 10 ampere, the relay used which is B. This protect the BC section. When current increases the value by 12.5 ampere, then the relay which is installed at point A is used or operate. This protect the section of AB. But this current gradient system is that the entire protection is not operated. The reason I already discussed. So next we will learn the brief description of overcurrent protection schemes of radial feeders, ringman feeders, radial feeders, parallel feeders and ringman system, which is basically application of time graded system and current graded system. So we need to remember these concepts of time graded and current graded system, which is further used for the radial feeder, parallel feeder and ringman system protection scheme. So thank you very much to listening.